Thank everybody for coming. My name's John McNabb. The title is Vulnerabilities of Control Systems in Drinking Water Utilities. I'll warn you this won't be very technical, and I'll explain as I go along. I won't read everything in every slide. Sometimes I put too many words on the slide so people can pick it up later or to remind me what I'm supposed to be talking about. I come from primarily a water background more than an IT background, although I'm doing more IT now than I did than ever. I was a water commissioner for a small town outside Boston for 13 years, which is the political office managing the technical people who will actually run the plant. So from a water-centered view, I've been looking at security issues since I first talked at DEF CON in 2010 on cyber terrorism and the security of the national drinking water infrastructure, which led to a cover story in Hacker Japan, all in Japanese, so I don't know exactly what they said about me, and to a chapter in Weapons of Mass Destruction and Terrorism on general drinking water security. So I look at general overall drinking water security for physical as well as cyber or IT, and of course I need to delve. This talk is my work in progress on the control system vulnerabilities and security of drinking water supplies. So I've been taking this on the road to a number of talks. I gave an early version of this at Noticon last week. I'm giving it again to the official government group, the Industrial Control System Joint Working Group in May. And I've done a number of articles on drinking water issues in the New England Water Works Association Journal as well. Some definitions and acronyms: ICS Industrial Control Systems, DCS Distributed Control Systems. I might be falling into calling everything SCADA, even though technically there's different types of control systems we're talking about, but that's a term that most people are familiar with. It's not actually, everything I'm talking about won't actually be SCADA, but the concept is similar enough for what I'm talking about to use that. PLC, Programmable Logic Controller, that's what's shown. Oh, that's what's shown there. An RT, Remote Transmission Unit for remote systems. Why I'm giving this talk, again, is I see a lot of denial in the water industry and in DHS, Department of Homeland Security, on drinking water security. And since 9/11, the funding for drinking water security has gone down after the initial spurt in 2001, 2002, 2003. And even though the water industry knows that there's a potential threat from physical as well as cyber attack, they're not really doing as much as they can about it. And that's really where this talk ends, is talking about policy and regulations and standards. But I'll get through that by giving you the background on the hardware and software to some extent. So we probably all heard about the Illinois water hack that didn't happen last November. Got a lot of press, national news, the first foreign hacker attack of a critical infrastructure in the United States. Except that isn't what happened. So it was a little confusing. It looked realistic when we found out it was a Russian IP address on the logs, and a pump had burned out. But it really turned out that the pump had burned out. We don't really know why, but again, pumps burn out. That's what they do after a while, and things happen in a plant. So that's not really the interesting story. The interesting story is this was hyped all over the place, and it's now been shown that it actually was a contractor for the water system who was on vacation in Russia. He remoted into the system from Russia, but that's okay, right? So that wasn't a hack, but so that's one of the problems we see here, is people are remoting in from wherever. Space Rogue is going to be giving a talk on media hype in the IT industry at 1:30. I just spoke to him. He's going to be talking in more depth about the hype involved with this incident and what it could mean in terms of how people see IT and how the press handles it. I was just stressed, sort of as a water security person, that all the talk, when they thought it was a real hack, didn't really lead to anyone asking a question, well, are we doing enough? And then, of course, when it was shown that it wasn't really a hack, it sort of dissipated. The only other interesting thing is that even though the facts are that it wasn't a hack, you can still find people on the internet who do their research and only catch the first part of the story and say there was a Russian hack of a water system in November. So that's sort of what Space Rogue can be talking about to some extent. It's an urban legend that's not true. But does that mean we're safe? No. Officials from the U.S. Computer Emergency Response Team, CERT, spoke at another conference a few weeks ago, and they were quoted as saying that U.S. energy and water utilities are under daily cyber attack. They only cited 17 instances for water and energy that I remember from the article, and they talked about, so I don't know if there are more that they're referring to as well, but they fly across the country responding to purported attacks, and so they're saying that there haven't been actually attacks. We don't know if these have been targeted attacks specifically trying to get into the water system, or whether they just got to the water system because of a wide-ranging attack, you know, or recon or whatever. But some of these attacks have been spear phishing to the, so that looks directed that the attackers know what they're going after. Social engineering attempts, somebody saying they're from Microsoft, we think there's a virus in your system at the water plant, can you give me your password? No one's admitted that they gave their password, but we'll see. There's been a number of incidents of suspicious activity, no more information than that. The trouble is the information reporting is very spotty. Every water utility wants to not say who they are. They don't want the public getting upset that they might be hacked, there might be a problem with their water. So it's very hard to get actual information from anything that may actually be happening. The map here is from a study done by Team Simru 2008, showing heat maps of scans of SCADA systems. So they were just looking for SCADA systems in general, who's searching for them. And they set up a honeypot called Darknet that found that all over the world, this is just the one from Southeast Asia and China, people are pinging and trying to scan SCADA systems in the US. They don't know why, they didn't get any more information, but that, on top of what these CERT people were saying, shows that something might be going on behind the scenes. How important is water? We take it for granted. It's a critical infrastructure. Under national law, you can't eat, live, work, do much of anything with it if you don't have it for so long. It's a source of wars and conflicts since the beginning of civilization. It's been a target of terrorists also since the beginning of civilization. The recent Global Risks 2012 report ranked water supply crisis in the top 5 for the likelihood of it happening and for the impact. So in general, water is very critical to everything, and so attacking it is not illogical from a attack, you know, if they're trying to harm society in general or the U.S. How does a water utility work? So a little one-on-one background here. I think we all have an idea. I may have more than most because I ran one for 13 years. But you have a source, you've got a reservoir or river, surface water, or you have wells. You have dams that can impound a river to create a reservoir. You've got treatment where the process control comes in. Finished water storage, which is what we usually think about as water tanks. Those are called finished water storage. You get distribution, which actually is the most vulnerable part of the system because there's thousands of miles out there and no one's really watching them. The good news is they're underground, but the bad news is you can get to them through the hydrants and you can't watch them all. Like we have CIA for IT security, confidentiality, integrity, availability. They've got pressure, safety, and availability. The people running the water system, their responsibility is to keep the water flowing, meet the regulatory standards for safety, for biogens, for chemicals, for toxins, for bacteria, and then maintain the pipes and the capital infrastructure, which requires issuing bills and collecting revenue, of course. Control Systems 101. The pictures here, this is the old control system, control panel at my water plant. In the good old days, before we computerized everything, it's a Fisher Porter or Fisher Bradley. I get them mixed up. It looks like a toy. So each of these are separate electromechanical connections to like the chlorine pumps. This is a wire. This is a pen register showing the level of water in the water tank, finished water tank. There are various knobs and switches where you can manually, make changes. There's a certain amount of automatic control we could do with those as well. But in around 2005, we moved to a fully automated SCADA, we say SCADA system. For the water plant itself, its process control is called a distributed control system. and for the distribution system is what's usually referred to, what's technically SCADA, because it has remote units. So here, with one screen, you've got a whole picture of, here's the water plant. There are readouts. It's very hard to read, but it'll give you the levels in digital format for what the level of the water in the water tank is, and for other, for the dam, we have a dam, so it would have the dam controls also on there. So it's all point and click though. You're on here, the system's running all the time. You point and click, you can make a change. It's very, called the human machine interface. Brief, again, I'm not a SCADA industrial control expert, so I'm glossing over some of these, but I'm just trying to give a flavor so you can understand when I get to the vulnerabilities what the capabilities are. So the one thing I understand the most is human machine interface. So you're sitting in front of a computer. It's usually an XP box. It could be Server 2003 when we were doing it a few years ago. It's probably still Server 2003 in many cases. Some have them on Unix or Linux systems or BSOD, but Windows is a common format. So you've got the human machine interface, which we saw. You've got controllers that go to the different actuators and sensors. So I'm going to get to showing some of the process in the plant and some simple examples, and the control process. So it also have to, you want to see what the inputs are and the outputs. You want to have alarms for the disturbances. You've got sensors. You've got a controller in between to the human machine interface that can have some level of control on an automatic basis. An example of control system hardware, the PLC, the programmable logic controller, input, output. It's sort of the translator. It connects to the sensors and the actuators that actually can turn pumps on and off and valves on and off, and translates it so the SCADA system can read the signal. And ICS, Industrial Control Systems, is different than IT, and this is some of the ways it's different. The focus for control systems is safety, 100% availability. It's going to run all the time, as opposed to security is more of a focus for IT, at least we like to think so. 99.5% availability, you can plan some downtime, but for a control system, you don't have downtime. It's running all the time in most cases. Aged equipment, most of the equipment's been there. Control systems predate modern computers. They go back to like the early 1900s with electromechanical systems and in the mainframe era. But there are a lot of systems that have been there for decades. The language is different. The vendors are different. We're all used to routers, switches, IP, Ethernet, digital. There's analog and digital with control systems. There's different technologies involved that aren't strictly integrated circuits or computers. So here's a diagram of my water plant, and I purposely don't name the water plant in case something gets out in the news and someone says John McNabb was saying how to hack the X community water plant. They wouldn't like that back home too much. So this is a diagram of one of our consultants of the process in the water plant, and I won't go through the whole thing, but just very simply. So here's the reservoir. It goes into what's called a wet well, a raw water well. Then we add chemicals, potassium permanganate and lime, which changes the pH so that the other processes can work as intended. Coagulant to take out the big stuff. Polymer to further take out solid matter. Most of what a water treatment plant does for drinking water is it takes crap out of the water, solid matter. Especially from a reservoir, you get leaves, you get pieces of things, and you want to clean that out. So before you go to the filters, though, you don't want to clog the filters with everything. So you coagulate it, you have it settle out in the sedimentation basins, then you run it through the mixed media filters, and what's left over goes into the wastewater slump, into lagoons that evaporates the water, or the supernatant we call it, goes into to the water supply again, because that's now safe. And usually before 10 years ago, we used to add chlorine at the beginning because that helped actually clean out the water and oxidize contaminants. But the EPA came out with a new regulation because they determined that it caused a potential carcinogen called triomethanes if you had too much chlorine in the water. So we had to move the process to redesigning the clear well, which is the last step of the process where the water sits until you pump it out to the water system, to the distribution system. And we just add the chlorine at the end. So the most critical thing here is chlorination, because even after you've removed all the solid matter and you've oxidized with the ferric chloride instead of the chlorine, the contaminants, you still have to disinfect it. So a key thing is, chlorine. You have to have a certain percentage of chlorine. So the process control system would, the human operator would say, okay, we're going to be processing water at the rate of 1 million gallons a day. We have a small plant. It went up to 3 million gallons a day. That's a small plant. And then the algorithms in the control system would tell the chlorine how much actual chlorine to put in to reach the required concentration. And that's a prime place for someone to mess with, because chlorine is so important. Now, if we look at, here's a diagram from a document trying to explain SCADA, and they gave an example of a water system. So process control is really what you're talking about, distributed control system in the plant, the treatment process itself, technically. The SCADA, or supervisor control and data acquisition, term usually means the remote systems. So we have a remote water tower. We only had 2 water towers, and we had a dam, and that's all. But many water systems will have valves. They'll have pressure zones where they have to turn valves on and off, and pumps, and they could have a wide variety of these. But for my system only had 1 water tower, so this is a good example for me. So you pump the water from the plant, from the clear well, through the high lift pumps, add the chlorine, but you also monitor the chlorine. They put SCADA computer here, okay. And we also had 2 well fields, so you could draw water from the well fields, and you want to keep control of all that. So that's what the SCADA does. It gives you readouts on it. Again, back at that one computer screen, you can go to different screens that show, here's all the wells, here's the tank, and you can drill down into them as well. So what's the potential effects of a cyber attack? I won't read all this, but this is the laundry list of potential effects, theoretically, that a task force that developed a document called Roadmap to Control System Security in the Drinking Water Sector came up with. Modify the control system software, unauthorized changes, block data, send false data, change alarm thresholds. Okay, this is all sort of generic, what you can do to a computer system or a control system. But I'm going to get into what specifically that could mean. There have been real hacks of water plants and control systems. It's a short list because no one tells us anything, but some have made the press. In 2000 or 2001, news reports give both dates, but a disgruntled former consultant from Marucci wastewater system in Queensland, Australia, accessed the pumping stations from the wastewater plant from his laptop because he had the passwords, so not much of a hack there, and released 800,000 liters of sewage into waterways. And that's like the big story still. Harrisburg is a water plant where not the control system, but the IT computers were infected with regular old malware. But again, these are the ones you always hear about because these are the only ones we really heard about. Recently, at a conference in Europe, some FBI officials slipped, I guess, and said there were 3 attacks on city SCADA systems in 2011. They didn't say if they're water or sewer or power, but another indication something's going on that they're not telling us about. After the non-hack came out in Illinois, a hacker named PR0F, Prof, I guess, claimed he accessed the South Houston drinking water plants and put images up on pastebin of their system. So it's not been proven that he actually did that. I haven't heard of any arrests. We know the FBI was investigating, so he may or may not have done that. But he reported that they had an easy-to-hack 3-digit password, which again is one of the problems because you find that a lot. And the Repository of Industrial Security Incidents, I think is the acronym, they get information from the grapevine. Quarter on this, I can't always get their reports because they cost thousands of dollars, but the news reports that come out every year about their reports that they're selling show continually increases in attacks or potential attacks on industrial control systems. So I try to think, well, what really has happened? And so I did a computer search for computer glitches or malfunctions or Grinches or for water systems. And here's a laundry list of things that actually happened that were blamed on a computer glitch. prevented a water tank from being filled. And now it's important in terms of the pressure, the PSA, the pressure that's required, you have to have at least 20 PSI, pounds per square inch pressure in the distribution system to keep bacteria from getting into the system, from inflow from the water that's in the pipes in the ground. And so if you get below that, you've got to issue a boil water order in many jurisdictions. The pressure is provided two ways. One is the height of the water in the tank, or the turning on the high lift pumps at the water plant. Those are equivalent ways to establish the pressure. So you always want to have a certain amount of water in the tank. So if your pumps go out or you're not running the pumps, you still have adequate pressure. On the other hand, in Howard, Michigan, a water tank overflowed because the sensors that said it was reaching a certain level presumably weren't giving the right information or failed. Water production stopped cold. This is interesting. False low pressure reading turned on pumps at Blue 7 water mains in Jersey Heights. The other aspect is information to the consumer. So prevented reverse 911 calls about a water main break in California. Erroneous water bills. I've got a whole set of research on wireless water meters and the glitches that can happen with those. Erroneous shutoff notices. And there's very little on this Lewiston one, but this is potentially the most serious type of thing, is that there's only like a couple lines here you can find on internet reporting and nothing publicly available, but apparently in Lewiston a few years ago, the chlorination shut off mysteriously. Now, it could have been mechanical failure, but where I see it referenced, they talk about control system failure. So we shall see. So the trouble with talking about this is the information is sketchy. So I'm going on all the information I could dig up and the analysis. So can you poison the water in a water distribution system through hacking the control system? Possibly. Again, shutting off the chlorination. And of course, like Stuxnet did apparently to the uranium centrifuges in Iran, you change the operation of the centrifuges or the chlorine pump, but you also change the sensors. So you turn the chlorine pump off, but you tell the sensors to still report that it's giving the right concentration. You could change other chemicals, but again, that's in my view, that's the biggest thing you could do. What that would do for at least a day or so until the community recognized it, is it would cause gastrointestinal illness and diarrhea and other complications from that. And diarrhea isn't funny, people can die from it. You can cause dehydration and death, and then you can get other diseases popping up the longer that this was occurring before they put the boiled water in. So again, it's not a big stick, but if a hacker, say, did that for 20 communities for a day and claimed credit for it, that would have spread panic, terror, which is of course the ultimate goal of a terrorist. The most effective way to poison water, I've looked into this, and other people have looked into this, is that you inject poison, say from another building, and this diagram doesn't show it, or from a hydrant. And there are studies on this. The American Water Works Association had an article in the January 2005 issue where someone did a technical study showing if you had one of these type of very toxic substances and you put X amount in this location, and you have to have a hydraulic analysis of the system. You can just do it anywhere and you'll get somebody, but if you really want to get like a certain building, which is the most likely use of this, you would want to know what's the water flow, what's the speed, what's the volume, what's the situation with the valves, does it always go in that direction? Does the direction change time of day? So you need some local knowledge, but it's not out of the realm of possibility that this could be used. Actually, Al-Qaeda or some fellow travelers were stopped from trying to do this at an embassy overseas a few years ago. I think the FBI concluded that they weren't necessarily going to succeed, but there was a plan in the works to do that for one of our embassies. And so the bottom line for all of this, for protecting water supplies and public health, is a real-time contaminant monitoring in the distribution system. And the EPA is working on that, and they have some pilot programs going on right now, because that's the ultimate end game type of solution. You need to find out what's in the water, and there are technologies that can very quickly identify common markers for contaminants that can be put in water supplies. The question is, do you know where to put them? How much do they cost? and how all the water districts are going to put them in. But my big question is, are sensitive U.S. government buildings protecting the water? So I saw a good, there's a show on the History Channel about America's Book of Secrets, which is interesting, and they talk about protecting the White House, protecting the Pentagon, and they never talk, of course, about the water supply. So I hope they're doing it, they're just not telling us. But someone's got to be doing real-time, the protection is, monitoring the quality of the water in a building. But for a high value building for us, that's worth the money, so you're secure. So we'll see. I don't have an answer to that question yet. I'm working on it. Potential attackers, this is the standard list of attackers. There's actually a lot of copper thefts at the water and wastewater plants. Copper, you can get money for copper. So let me go through. I got some slides where I talk about a couple of these. So we're trying to look at the threat landscape. Terrorists, that's the first thing I looked at in my talk in 2010. That's how the media thinks hackers look like. So I put that up there. Al-Qaeda has repeatedly threatened to poison the U.S. water supply. They haven't done it yet. I shouldn't say yet. They haven't done it. But we know that they've got a motive. We know that they're working on physical means of doing it because after the U.S. invaded Afghanistan, they raided Tarnak Farms, which is a training camp for Al-Qaeda in Afghanistan, and they found a wealth of documents, including this piece of paper here where they were examining potential toxins to put in water supplies. So even though that was busted up and Al-Qaeda is weaker, the RAND Corporation estimates it's still around for the next 10, 15 years. And especially since we know that they may be working with other nation states, we can't rule that out. Of course, poisoning water isn't the thing that terrorists like to do. They like blowing up planes or something that's more spectacular with bombs. So there's a debate in the anti-terrorism community whether that's really even likely. But again, we know that they have a motive. They're talking about it, and they've been researching it. So, but again, are terrorists, Al-Qaeda especially, likely to use cyberterrorism, which again is debatable whether it's really happened or not, except for Stuxnet, to actually attack a physical infrastructure? And again, most analysis shows that they're not. They use the internet like everyone else does, or other groups do. They use it for fundraising. They use it to steal money through crimeware. They use it for recruiting. They use it for propaganda. They use it for organizing. They use it for planning, which is all very important, of course, in trying to figure out what they do. If you can hack into that, get that information to see what they're up to. So no one seems to know whether they're one of the people who are grabbing onto Stuxnet or Dooku to see if they can repurpose it to attack water supplies or other infrastructure. So that's more of a question now than it would have been 2 years ago before we knew about Stuxnet. Nation-state actors, Iran has Cyber Hezbollah, which is using the internet, but again, the usual hacktivist type things, propaganda, defacing web pages. But they have capabilities that, again, if they're doing the research behind the scenes, they might be also looking at a Stuxnet type attack. North Korea, cyber attacks, again, that's mostly web pages, not a Stuxnet type attack or whatever. So those are the usual suspects, but again, most of it is defacing web pages, taking down websites, which is usually temporary. Industrial espionage, we've got crimeware coming out of Russia and almost anywhere else. So, but the most likely, the proven attacker are insiders, like Victor Bowden, the guy in Australia. There was a recent incident in Key Largo where a former employee hacked into, well, after he left, he still had the passwords. So here we go again, and he hacked into the, he accessed the Key Largo's business systems and stole some documents. So again, that wasn't a control system, but again, it was a hack of a water system. Al-Qaeda has reportedly been trying to recruit insiders to get information at water plants. So another indication something may be happening behind the scenes. So this is the one big thing that anyone can point at as being a legitimate threat, insiders, especially if they're disgruntled for, like Victor Bowden was, for not being rehired, or this Key Largo person for being fired. But also you may find people who are sympathetic to Al-Qaeda or some other group or homegrown terrorists who want to help with that. So that's a very important training type thing for security standards for drinking water systems that needs to be done. Potential attack vectors, I won't read all these. USB, I'll mention a little later, Stuxnet type attack. Modems, a lot of the legacy systems were modem accessed by the integrators, they're called, the consultants who built the systems. And many of them are still in place. So that's a potential hole that most people will not be aware of at a water plant because they're not really using them anymore. They just leave them on. So I asked, when I learned about it at my plant, I asked them, well, can you turn it off until they really need it? But ICS people don't really think about security the same way as IT people do, because they have to have 100% availability, and they're not really set up to be secure inherently. Internet access. So one of the bigger studies on this was Erin Leverett, is a master's thesis in June. He did a massive Shodan inquiries and found 10,000 plus SCADA systems online. He didn't say which ones were water, which ones weren't, but that confirms what we hear from other researchers at other hacker cons. Usually report, hey, I was online and I was able to get into this water system. It's not hard to do, apparently. So we don't know how many SCADA systems for water systems are on the internet. No one's done a study like that, and I don't have the resources to do it right now. That might be one of my resource requests to try to get a grant, because we need to know what the extent of the potential exposure is. But it's definitely proven that some of them are out there. Many with simpler default passwords. Again, at my plant, they're running the HMI all the time, and they're not having to put their password in every time they do anything. That would slow them down. So if you can get into the HMI and get to that point and click screen, you can do lots of stuff. Or if you infect that computer and get a rat in, a remote access tool, you can do things. So again, I'm not saying just because they're in internet, they're going to be hacked, because obviously we all know that you need to know local knowledge, you need to get some recon, some information on the systems and the process in the plant. But again, that's a first step that shouldn't be there. Thumb drives, okay, or other removable media. A lot of research is trying to get the word out that the air gap is not reliable protection by itself. The Defense Department found that out in 2008 when a thumb drive that someone picked up overseas apparently got into their standalone system and infected their classified system. Stuxnet, I just changed that site earlier. There's a lot of news now that it was a double agent in Iran. It was some Israeli, most press reports say Israeli, but who knows. But the thinking beforehand that it might have been a Siemens engineer who picked it up and then came to the plant to service the system. We don't really know. So other removable media can also be used. So this again, this is part of the security training and measures that need to be taken that, as far as I can see, aren't being taken at water plants. Remote access. Okay, Mark Mafreet from EI Security, if I got that right, was in the press early last year that he was hired to do a penetration test of an unnamed Southern California water utility, and within a day was able to get in. And I emailed him and he confirmed, he couldn't give me many details, of course, but he got in by finding I assume a phishing attempt, he didn't say that, to an employee who was remoting in to the system from his home. So that's a very common thing as well. In my plant, we were able to remote in to our video surveillance system, which of course was built in to the business system at the plant and may have had links to the SCADA system. So remote access is very convenient, but it's a big hole because, again, your weakest link is any employee who responds to a phishing scam or gets infected. And if the attacker's lucky enough to get one of those who gets on the system a lot, they can get access. And, and we should have learned that from the Russian IP address on the Illinois plant. Why are you remoting in from Russia to make changes to a SCADA system? VPN is a way to further protect it, but it has vulnerabilities, and of course the Microsoft RDP vulnerability ups the ante a little. And mobile phone apps, let me get to that. Okay, what could go wrong? So there's a number of these coming out now, very convenient. So you get your iPhone or your Windows phone or your Android, and there's an app that links into the SCADA system or the DCS system or the HMI, and you can do everything from your own mobile phone. Now, I'm not a mobile phone malware expert, but all of us can see in the news that Android's being hit all over the place, and that iOS is now getting a lot of malware as well. So again, there's no details. I don't have any numbers on how many of those are being used, but that's another big hole in the system. Because what could go wrong? Everything could go wrong. Okay, focusing back on the national water infrastructure, unlike the electric grid, actually there's 3 grids I learned. There's the East, the West, and Texas. A Chinese graduate student had a paper out 2 years ago where he calculated that if you hit 1 or 2 nodes in any of the grids a certain way, you can knock out the whole grid. But we already know that because of the 2003 blackout, the 65 blackout. There's been a lot of blackouts in the Northeast because a tree limb hit a wire, or there was a surge at a power plant or a remote station. So unlike that, there's the grid or the infrastructure for water, but it's not a grid. They're all separate. They may have connections for sharing water or even a one-to-one connection for information, but they're different. So you can't attack all of them at once. That's the good news. Unless you did it through, and this is far-fetched, but I gave a talk at this at American Water Works Association a few years ago. The one commonality is treatment chemicals, and chlorine is the one used the most. Interesting I say poison chlorine because, of course, chlorine is a poison. But it's theoretically possible, although improbable, that a certain radionuclide could be used to contaminate it that no one would check. Highly improbable, of course, but that's the only way you really can get all the water systems at once. Could you get them all at once through the IT systems? Again, not all at once because they're individual. The only commonality, again, is there are a number of water systems that are part of conglomerates like American Water, U.S. Water, Aquarian Water, and to the extent that their business systems are connected across the country, that's a potential way to get more than one at a time. So it's a fragmented infrastructure. Every water system design is different because it depends upon what is the quality of the water there and what are the treatment needs. And so there's no standard drinking water treatment plant design. There are standards, there are standard ways of doing it, but everyone is unique, and it changes over time. So, and what I've seen from my plant is that the SCADA system, the control system, evolves over time. Ours from a simple analog electromechanical control through that blue control panel to the current computerized HMI system using XP software. You get different layers of things going on at the same time, and it may not be totally understandable from a hacker getting in for him or her to know what's being run at the same time. So it's a difficult problem to recon, and it would take time and effort, which of course any good hack would take. So it's not impossible, but the fact that it's a fragmented infrastructure, they're separate and unique in many ways, is probably the best defense. Except, of course, we're hearing that there are attackers that are doing recon at least, and potentially attacking them through phishing and other means. So, and the other thing is that there's $1 trillion shortfall. It was calculated by the American Water Works Association to fix the infrastructure. The pipes are old, they break, they leak. The treatment plants are old. They cost money to replace them, to meet new standards, to replace broken machinery. And the Onion had this great video where they had this supposed Al-Qaeda guy say, "Hey, we're not going to attack your transportation infrastructure because if we did, no one, and claim credit, no one would believe us because it breaks all the time on its own." And that's only partly funny because it applies to the water system. There are 24,000 water breaks a year, leaks 7 billion gallons of water. There are dozens of water waterborne disease outbreaks from the water that's not properly decontaminated or treated. So there are water breaks all the time, power failures, there's glitches, as far as we know. How many of those glitches were really glitches? So there's a lot of noise. So for a hacker a malicious hacker to get out there and attack them, it would have to do a lot to get over the noise. And another lesson is that from the strategic bombing survey, World War II, the precision daylight bombing the Allies performed did a lot of damage, but it was the survey concluded that only when they were consistent and continual and thorough that for any sort of any infrastructure that they were successful. And the lesson applies to a cyber attack on the water system of the U.S. It would have to be a massive attack over many systems to have an impact that would rise over the noise and have an impact on the U.S. Okay, SCADA vulnerabilities. Again, normally my old system I showed you with the blue Fisher-Porter panel was isolated. Except for a radio communication to the water tank, everything was in the plant. So there's no, all your security is physical security. If you can't get to the panel or into the plant, you can't affect it. Well, that's different now. Now they're being networked over Ethernet and the internet. And though a lot of them are controlling it and not having easy access to it, a lot of them still have IP addresses on the internet. Digital Bond's done a lot of great work in this in documenting vulnerabilities. There's the ICS CERT is working on as well. DerbyCon, Rios and McCorkle were astounded at how many vulnerabilities in SCADA systems they did from fuzzing them. They did in 100 days, they had to stop. Luigi Aramello, I don't know if I spelled his name right, he continually finds more SCADA vulnerabilities. So this is sort of a graph by quarter of how many have been discovered. Not how many are out there, but how many have been discovered, and it's exploding. This is from Digital Bond's initial Project Basecamp study of very popular systems looking at types of vulnerabilities. So there's been an explosion of discovery of vulnerabilities outside of the fact that they're inherently vulnerable. And the fact is, too, is a lot of manufacturers like ABB are saying, no, we're not going to patch this because they should replace it. Well, maybe they won't replace it because you want to keep it in place for a while, and also water plants don't have much money. So here's the new Forever Day or iDay bugs. So there's going to be more and more of these where the manufacturers just aren't going to fix them. And it's going to be known, and what's that going to mean? It's probably not going to be good. Again, very generally, from a good paper by Jeffrey Daniels, who testified before Congress. He's from the Sandia National Laboratory, done a lot of good work on this. Again, the master is the HMI system. The slave is usually the PLC, the programmable logic controller that's monitoring like the chlorine or the treatment or the water storage tank or whatever. The biggest one is to compromise the master. In my mind, because if you control the HMI, the point and click system, then you can tell it anything to do. And it's relatively easy from a Windows XP platform, which probably hasn't been patched ever. The one in my plant was SP2 a few years ago, and it's never on the internet, right? So there's no need to patch it. So, but of course, what Stuxnet did is it compromised the slave and sent incorrect reporting back, saying that don't know the centrifuges are running properly. So that's just sort of a taxonomy of using Modbus as an example of different ways to disable, disrupt, write, read data. Likely attack scenario, again, I think I've already covered this. You've got to have local knowledge, and the thing is, you can find that. Okay, the real outcome of my talk, I'm running out of time, I find out, is the water security is weak, and because the standards are weak. Idaho National Labs did a 2005 report based upon the common criteria for ICS security, which is a successor to the Orange Book, right here. And they could only find a very small document from the American Water Works Association on, well, they've got a large book on security, and there's one chapter on control system security that has a lot of gaps. And so I went through it carefully, and out of 51 specific standards where it was even addressed by AWWA. There were 8 or 9 that weren't even addressed. It failed 34, meets 15 partially, and matches only 2. The need to avoid power failures and need for employee training. But I don't see much employee training going on, actually. And no one's enforcing American Water Works Association standards anyway. So that's the big hole in the whole thing, is the lack of standards. And for example, this is like shooting fish in a barrel, but I just listed some of the more recognizable, to me anyway, standards. Security alarms, they don't have, to make sure you're alarmed properly to alert you to events, no. Cryptographic key management, no. Data authentication. Replay detection, no. So again, in the control system, replay detection is a good one, limited priority service, so you make sure that a high priority is actually can get through as opposed to a low priority. That's another way to get through. Technical fixes are needed. It's not necessarily a technical problem, except that every water plant is unique in many ways, including probably their control system. So you can't just take one from the electric industry and say, here, apply that. Someone's got to write up one specifically for the water industry, and it doesn't exist yet that I've seen. The obvious one is take SCADA off the internet. They need to patch the HMI platforms, lock down access. There are general standards, ISA, and the GAO did a report a number of years ago talking in general about control system security, saying there's already too many standards. There's too much information out there in general on control system standards. If you're trying to protect one of the industries, you need to focus and be specific about it. So the only thing that's really happened in the water sector was after 9/11, they were required to do vulnerability assessments, which did not have any questions on ICS security. Again, they're not enforced. They only had to do them once. As opposed to the electric industry, under NERC, they have to do vulnerability assessments every year, and they're evaluated and they have to meet them. For water, it was a one-shot deal, 2003, 2005, and no money was provided for the 1.6 billion for the easy things to do, like fences and physical security. So a lot of bigger water plants, bigger districts had the money and did more, but it was left up to water districts to decide, okay, you did this vulnerability assessment that you don't have to send to anyone, no one's going to read it and evaluate it, you decide what to do. So the next step was March 2008, a task force, the Water Sector Coordinating Council Cybersecurity Working Group. I love these long names. I don't know what the acronym for that would be. They came up with this roadmap to secure control systems in the water sector. Oh, so there's a plan, right? Well, it's not a plan. It had some okay goals, but it wasn't a plan. I'll get to that in a second. And again, so here's their milestones. This is right from the report that came out in 2008. So by 2009, they're going to isolate ICS from public switch networks. How are you going to do that? That's all they said. And the biggest problem, let me go back, was that the major problem is for the water industry, the water utility operators that think the business case has not been made to spend money on security. So they're not going to do it on their own. And they're really not going to do it because they're lacking money to even fix their infrastructure, their pipes and their treatment plants, unless they get money from the feds or the states, which isn't happening. So there's no progress. I've emailed the head of that group and the American Water Works Association, and they basically say, no, nothing's happened. No one's in charge. There's no work group who's looking at how we're going to implement this. So I'm going to give this talk to the ICS Joint Working Group, in the official government group that is an umbrella over this whole process. And we'll see what they can tell me back in May. Conclusions. So I think I've established there are potential threats and threats to the water infrastructure. However, the people running them don't think the business case has been made to fix it. There's no requirements, no oversight, no funding, no planning. There's got to be some process, and I may not be the right person to do it, but someone's got to come up with requirements. There's got to be money. They're going to be evaluated annually like the electric industry is, and it's got to be done regularly. Here's the road to nowhere, which is the roadmap to control system security in the water industry. So outside of all the technical issues which have to be addressed, there's no standards and there's no process for reaching them, I'm afraid. Thank you. And complete the survey, please. Okay, thank you.